Welcome to Supermicro 5G Live Forum and learn how Supermicro 5G solutions are better, faster, greener. Better with the broadest portfolio of 5G and telco systems for optimized performance, including compact 1U servers, short depth 2U servers, wall mount, compact and mini ITX edge servers, pole mounted servers, as well as 2U twin architecture and SuperBlade solutions. Faster, industry standard data center class performance like the short depth 2U Ultra server with hyper speed and hyper turbo technologies for ultra low latency. And greener with reduced TCO and environmental impact using resource saving architecture, high efficiency power supplies, free air cooling, sub-assembly refresh, and long life chassis components. For the broadest, most reliable, fastest, and energy efficient 5G and telco products in the industry, join us. Now, welcome to the forum. Ladies and gentlemen, introducing Michael Clegg.
Welcome everybody to the Supermicro 5G Live Forum. Supermicro is a US public company headquartered here in San Jose with global operations. We have an office in the Netherlands that looks after the Europe, Middle East and Africa, and an office in Taiwan that looks after our Asia Pacific region. Supermicro invests heavily in engineering and R&D. This has enabled us to grow our revenues consistently over the past 20 years. This has also enabled us to become a top 3 system server provider worldwide. So for those of us who have been working from home during the COVID time, we have really come to appreciate the benefits of high-speed broadband and the flexibility that Wi-Fi brings. What we will see is that 5G is going to bring the same benefits to the wide area market. So let's take a look at the evolution of mobile networks. 3GPP, which is the mobile network standard setting body, sets a new generation around every 10 years, every decade. Typically, each new generation introduces one major new feature into the network. But 5G is a little different. With 5G, there are many applications and services as well as network architectures being introduced. So much so that it is actually coming out in multiple phases. The first phase, release 15, which is currently being deployed, is called non-standalone mode. In non-standalone mode, you connect a 5G new radio to an existing 4G core. But actually, many 4G radios can be software upgraded to 5G. Doing that, and using a technology called dynamic spectrum sharing, we can upgrade those radios and have them simultaneously work in both 4G and 5G mode. So for a time they will operate in 4G, initially mostly, with a little bit in 5G. And as we get more 5G terminals, they will operate mostly or eventually completely in 5G mode. But the real benefits of 5G come when we do release 16 standalone mode. In standalone mode, the core network architecture changes from being traditional fixed function hardware to a cloud native architecture. With a cloud native, they start to operate and look like the data center solutions that we are used to. And with a cloud native network, the software runs on software and hardware is disaggregated. So you have software that is now a virtual network function running on standard off-the-shelf compute hardware. So let's take a little look at the 5G ecosystem. So here on the ecosystem, we have the core in the middle. And around that, we have three application categories that have been defined in 5G. The first is enhanced mobile broadband. This is where your network is faster and the capacity is much greater. The second part is massive machine type communications. With massive machine type communications, we can now connect the Internet of Things devices to the 5G network. For those of you with smart homes, you will know that smart homes became a lot easier when Wi-Fi became pervasive. Because now you could put a sensor into the home without having to run a wire to each sensor. With 5G, we will be able to connect many devices to the 5G network without having to run a separate broadband network. But the real part of 5G that is unique is ultra-reliable low-latency communications. With ultra-reliable low-latency communications, we can start to do functions and applications that are not really possible on 4G. So for those of us who've been using these cloud communication services, which is most of us, we will know how it is like when the latency is weak. Somebody will be talking and stop, and there's an awkward gap where everybody interrupts each other until you start talking again. But when the latency is low, the communications is real time. It feels far more natural, and it happens the way it would be if we weren't working off the network. Ultra-reliable low-latency communications will bring that same capability into the 5G network. So now we can start to do things like automated guided vehicles, autonomous driving, drones, these types of applications, augmented reality, virtual reality, that rely on a real-time connection. So let's have a look at the network architecture as deployed. On the bottom plane over here, you see your 5G network. You have your data center at the right-hand side. Remember, 5G with cloud native looks just like any other IT data center. And we have some talks today about the servers and products we have for that. This goes out to the radio access network, the RAN, and even the RAN network is following this disaggregated software and hardware model. And we will be speaking about that with our partner Telefonica and also some products. But actually going further, even the networking protocols can be disaggregated, and we will talk about that in an example today as well. At the top you have your application plane. You will see that these two look very familiar because, again, everything is now cloud native. You have a data center in the cloud, and you have your terminal and your application processing. But in order to take advantage of that ultra-reliable low latency, you also need to move compute closer to the application. So now we have edge compute, multi-access edge compute, or MEC. So what we're going to see with 5G is that it is going to drive a completely new market in edge compute applications and services. Now, a benefit of 5G is when the traffic comes in from the network, you can do a local breakout and go straight to that edge compute that is co-located with a radio access network. So the traffic no longer has to go all the way to the core and come back again where you suffer that high latency. To keep the low latency, you can break out locally and process locally. So this is what is going to make these ultra-reliable low latency communications possible, and we'll see a growth in edge compute. And we have some products and services that we will talk about that today with our partner T-Systems. So as we go forward, we really see the 5G network is going to be quite revolutionary. Edge compute by itself is going to drive many new applications, including augmented reality and virtual reality, and other services that will require real-time communications, as we can see on this slide. Now, Intel has been very instrumental in driving the industry towards this disaggregated software and hardware model. They have been a big proponent that general-purpose computers now become fast enough to operate on a 5G network. And with that, I would like to introduce Caroline Chan from Intel. Caroline is going to speak to us a little bit about Intel's insights and the activities that they have been doing in 5G and together with Supermicro. So with that said, I'd like to hand over to Caroline. Thank you.
Introducing Caroline Chan.
Hi there, this is Caroline Chan. I am part of the Intel Network Platform School. Thanks to Supermicro to invite me to share with you what Intel thought about 5G strategy, as well as how it really moves the edge forward. So let me share with you what we thought, where the industry is going. So there, we are really at a juncture that there's three megatrends that transformed the industry as we know it, the telco. There's really three elements. The first one is the proliferation of cloud all the way to the edge. So the cloud services, as you evident from today, you've seen like the Affirm acquisition by Microsoft, the AWS going to wavelength. Everyone's really pushing the cloud computing to the edge, to the enterprise. The other one is the AI. You see AI everywhere, especially with the pandemic that we are facing today. AI applied to all aspects of our life. What really makes this all possible is the fact that we've been seeing a rapid cloudification of the network. Just by making the network more cloud-like, we're able to carry much more data much more cost effectively to allow the AI data to be brought onto the cloud for training and then to take it back to the edge to be applied. So there's a lot of good things happening, and right in the middle is something we call 5G that really made all of these possible. So then we looked at what have we seen today, the network and edge compute. What are the opportunity for all of us in the ecosystem? Because the fact that 5G is rapidly bringing all this together, we're seeing a significant growth in opportunity. Look at these numbers that we've compiled from different analysts. There's just IoT silicon alone is $30 billion. So people have been talking about IoT for a long time. Until now, we have a lot of connectivity. We have 5G, we have CBRS, and we have this private LTE concept. Really brings IoT, all the data through the network to the cloud to be applied enhanced by artificial intelligence and machine learning. So we do really see a significant growth in these verticals. Network silicon, the estimate is $25 billion. It is not that far away. It's like 2023, 3 years from now. Of course, you've heard of autonomous driving. And just in China, for example, there is a connected cars happening, V2X. We've been partnering with Supermicro in that area. And here in the US, FCC is going through the motion to put out a frequency spectrum just targeting V2X. So as you can see, there's plenty of opportunities for us to go in together to win this market space. So I want to share with you some of the 5G use cases that Intel has been working on. These actually globally, it's not just within the US or in particular geo. The first one is really triggered by the fact that you have a technology transformation brought on by 5G, but really has been put in place long ago when we started looking at how do we push the network to be more agile, to be virtualized and software defined. Only by doing so, you have an infrastructure that can accommodate all those different use cases. So from the before, when we are doing 3G and 4G, we really designed the network to be very focused at one single spectrum efficiency, driving that is as a single purpose network. But today, when we see the network much more virtualized and agile, you are able to carry different type of workload on it. It's beyond just doing the connectivity. You have cases that you can run smart stadium, which we've been working on and starting with the universities, and now we're working on professional venues. Smart city, that is becoming even more important now that we're facing this pandemic, this crisis. A lot of things that we thought that was very like cloud gaming that is still going on, but through this year, we see a heavy usage of telehealth, remote education, started to take some of the things we thought that's 10 years from now to actually this year. So really becomes much more prevalent to all of us to take up the action and put that really put that into practice. So you see there's a consortiums, there is the US government started putting investment into 5G. All that trigger because you have both the new business opportunity as well as the necessity that really started driving this. So let's look at what Intel has done provide this network transformation journey. We started this way that more 10 plus years ago. We started by doing with the core networks, running the virtualization, and through with working with ecosystem partners like Supermicro. Today we see 80% of the core network is on its path of being virtualized. In fact, for 5G, every single core network RFP that we have seen all ask for virtualized core. So now the battle, it really started moving towards the RAN, the access network, which traditionally has been very difficult. It's very latency driven. virtualization technology was not built for that. But through the collaboration the Intel engineers as well as all the ecosystem partners together, working with VMware, Red Hat, and Wind River, and so on, we really started driving that latency down to something that's very tolerable within the 3GPP. So we are seeing a rapid proliferation of virtualization into all the way throughout the network. So having said that, really we need to start looking at how do we bring all of that together. So remember I talked about there is the cloud proliferation to the edge and the AI and the network virtualization. What that really meant is that we no longer just deal with a single model ecosystem. The ecosystem is much more rich, includes many different verticals. You can see that from the left where the open source and standards consortium, you see beyond just 3GPP, we have something called ORAN, which is a group of service providers really driving an open and interoperable network for 5G. We see TIP, or Telecom Infrastructure Project, which is Intel is a co-founder with Facebook, DT, BT, Telefonica, and Vodafone. The goal is driving the best known methods that runs in the cloud into the network. In addition, you see some of the symbols there called 5G AA, which is a 5G autonomous automotive. And we have even 5G ACIA, which is taking the 5G into different industrial verticals. So as you can see, this is no longer a homogeneous among type of ecosystem. We are seeing a varieties of partners coming in. That because 5G really runs on a broad ecosystem. The collaboration is very important. So Intel has something called Network Builders and Intel Developer Zone, which is taking our software, our silicon to the broad ecosystem, bring everybody together, the entire supply chain, all from the users to the to technology partners, to OEM, ODM like Supermicro, and to the service providers altogether. Intel just recently announced a 5G innovation zone up in Seattle, which we will be shepherding a lot of startups coming through, because we believe that this new ecosystem needs innovation, needs startups that bring in fresh ideas into this. So accelerating time to market becomes really a battle cry. So that's why we have Intel Select Solutions, NVI, and UCPE start driving different form factors, a wide variety in order to accommodate right varieties of use cases. So through this journey, we're very lucky to work very closely with Supermicro. Some of the success stories, we recently launched, Telefonica launched a 4G and 5G Open RAN trials in Europe, in UK, Germany, Spain, as well as Brazil, with Intel Supermicro together. We have other industry partners into this. This really shows that when we work together, we can take the most difficult tasks and running and virtualized. And T-System, which is a subsidiary of DT, they've set up an edge compute platform, delivers low latency performance for IoT applications, really becomes a center enterprise facilities running on an Intel-based Supermicro edge compute and servers. That fulfills our promise that 5G is not just for consumers. 5G will go all the way to the edge and to enterprises. So very, very excited for that coming up this year. We'll be working closely with Supermicro on vRAN, partnering in 5G and edge compute, different proof of concepts and trials. We'll be exploring some network as a service, which is really the holy grail that everybody's going after. So thank you very much for letting me to share some of that Intel strategy with you, and wishing you a safe, wonderful rest of the day. Thank you.
Introducing Maury Lin.
Welcome to Supermicro 5G Forum. My name is Maury Lin, Senior Director, IoT Embedded Product, leading edge computing innovation in Supermicro. The keynote session here is about the 5G and high-performance edge computing. After the great presentation done by Intel VP Caroline, Supermicro would like to continually share our innovation here with you for the edge computing deployment with the 5G technology. In front of you, you notice that there is a non-traditional rack-mountable machines. Yes, it's an outdoor computer. Allow you to deliver the server performance to solve the problem you have at edge for the telco environment. We understand the telecom and virtualization infrastructures suffering lots of challenge. Because of this, we hear lots of feedback from the partners and customers as well. They would like to decouple from the proprietary designed hardware, but they also need to keep the highly secured environment, cohesively exchange the data efficiently. Because of this, the Open Radio Access Network and the Open Radio Access Network Alliance become a very good options for you to think about. In the cloud environment, there's a lot of orchestration ready for virtualization. But when you extend your computing power to the edge, there's a lot of things need to be considered, such as the asset management, remote controlled, and also remote update. And also you need to keep the Xeon D performance with the Xeon scalable possibility for all the FPGA as well. All these things are very friendly for the data center environment. But at the edge side, all those beautiful things become very challenged. We understand. So that's why after we have so many experience in the data center for the core networks, for the high performance edge computing, GPU, total storage, all together here, we bring those technologies to the edge, but still stay with small form factor for indoor and also for the outdoor environment. We understand the coming future for the edge computing, not just about the high performance. There are lots of factors need to be considered. For instance, like the low power and high performance scalable architecture in a very secure environment. Because of this, from the cloud to the edge, it's possible to make this 5G O-RAN, MEC, SD-WAN, and UCP all together. And to make this possible, we also need to have the more aggregate intelligent gateway to collect the data. And fanless for sure will be very friendly to all kind of environments. We also keep the Xeon performance inside. Because of this, it allows you to scalable your architectures from data center and also allow your orchestrations extended through the channel all the way to the edge. It's a beautiful idea. And it's also a deployment now. We understand because of these combinations all together, customers will ask you to give you more choices to solve all kind of challenge they have right now. For instance, they will ask you how we are going to solve the problem together when I have the machine need to mount outside of data center. On the pole or on the wall. I have a different power source mixed with the DC and also AC environment. Do you have a platform allow me to switch in the different computing platform without changing too much? And we also have the front I/O design, allow you to do the easy serviceabilities. All this all combined together still cannot solve the problems. The machine need to be cloud native for the architecture's design, for the 5G, AI, and edge. To combine all this together, there are several things could be managed. We choose the one example to share with you is for the vehicle to everything, V2X. When the autonomous driving machines talking to each other, the latency will create a huge challenge. And the high definition camera collect all the data also need to process locally with FPGA. To make this all possible, then you need to have a Xeon performance stay at the edge and solve the challenge from the operation environment, and also continue delivering the performance. And all these kind of great thinkings will be shared with the following breakout sessions by many delighted guests and presenters. We hope you enjoy the Supermicro 5G Forum. Thank you.